Welcome back to the Deep Dive. We're here to unpack the most potent ideas in AI and really give you the insights to elevate your craft.
That's the goal.
And today, we're diving into something really significant. The huge potential of your AI and, maybe more importantly, the impact you can have with it. We know you're a Python beginner, maybe 6 months in, which is great, and you've already got a solid handle on prompt engineering. You've built customer support chatbots. That's honestly a fantastic foundation. Shows real talent for guiding AI.
It really does. You've built agents that can understand, that can react, but, what if we could push beyond just reacting? What if we could build AI that's truly intelligent, that's reliable, maybe even proactive?
Exactly, and that's what this deep dive is all about, taking that next critical leap.
And it's a leap with a really inspiring purpose behind it. You've told us your goal is leveraging AI to creatively and efficiently support domestic violence crisis response organizations.
Just think about that for a second. The stakes involved there, they're incredibly high.
Absolutely.
In contexts like that, the reliability, the ethical grounding, the smart decision-making of your AI, it's not just nice to have, it's essential. It could genuinely be life-saving.
Right. When people are at their most vulnerable, trust and safety are everything. We're not just talking about building systems that work efficiently. We're talking about systems that work responsibly.
Couldn't agree more. So, okay, what's our mission for this deep dive? We're unlocking agentic design patterns. Now, don't let the name intimidate you.
Yeah, it sounds a bit technical, maybe.
It can, but think of these patterns as your mental roadmap, like a blueprint for building AI agents that are genuinely intelligent, reliable, and proactive. It's about taking those prompt engineering skills you've mastered and applying them at a higher architectural level.
These patterns are really the blueprints that help you move beyond the reactive chatbots you've already built. They give your AI the power to operate with more autonomy, more safety, more effectiveness. They let it anticipate needs, protect users, and offer real help in complex, high-stakes situations.
So we're going to break down the key concepts, the technical terms, the architectures. We'll do it in a clear, engaging way, hopefully giving you those practical insights, those aha moments that make learning feel, smooth, intuitive.
Our goal is really to equip you to build AI solutions that are not just robust, but deeply trustworthy and truly impactful.
Okay, so what can you expect? What's the journey ahead?
Well, first we're going to tackle guardrails. These are fundamental for safety, for ethical operation. Absolutely critical.
Got it. Safety first.
Then we'll get into evaluation and monitoring. This is all about making sure your AI keeps performing well, that it stays reliable over time.
Which sounds crucial if things change. Right?
Exactly. Then we'll look at prioritization. How does the AI make smart, strategic decisions when there are lots of options?
Okay, making the right call.
And finally, we'll explore exploration and discovery. This is where it gets really exciting. Empowering your AI to actually uncover new insights, maybe even foster innovation.
Wow, okay. That's quite a journey. Let's dive in. This is where your existing skills get supercharged for that really critical mission you have. All right, first up, guardrails. Also called safety patterns. You can think of them like the really strict safety protocols in a hospital.
Or like the rigorous testing that goes into, say, a child's toy.
Yeah, exactly. They're designed specifically to prevent harm and make sure things operate reliably, especially when the consequences of failure are, severe.
And what's really key here, I think, is that guardrails aren't meant to limit what an agent can do. Right. It's not about restriction. It's about ensuring it operates ethically, safely, and as you intended it to, especially as it gets more autonomous.
Right, so they're like a protective layer.
Precisely. Guiding the agent's behavior, stopping it from giving harmful or biased or just irrelevant responses, basically anything undesirable.
Okay, and let's connect this straight to your mission-building AI to help survivors of domestic violence. Here, this isn't just important, it's absolutely fundamental.
It really is.
An incorrect piece of information, maybe a response that sounds biased, even just an off-topic comment. It's not just a glitch. It could actually make a dangerous situation worse. It could destroy trust. It could potentially lead to tragic outcomes.
Yeah, the stakes couldn't be higher.
So guardrails are really your first, most critical line of defense for doing this kind of AI development responsibly.
Absolutely. Without strong guardrails, an AI system can become unpredictable, potentially hazardous. It could be manipulated, or it might just fail to uphold the ethical and legal standards you absolutely need it to. Guardrails are vital for managing those risks and keeping user trust, making sure the behavior is predictable, safe, and compliant.
So how do we actually put these in place? You said it's not just one thing.
No, it's definitely not a single switch you flip. It's much more effective as a multi-layered defense. Think of it like layers of security.
All right, like concentric walls around a castle.
Kind of, yeah. That's a good analogy. A layered approach gives you the most robust protection. You can implement these guardrails at different points in the AI's process.
Like where?
Well, first there's input validation or sanitization. This means filtering out malicious stuff or maybe inappropriate questions before the agent even starts thinking about them.
Okay, catching bad stuff coming in.
Then there's output filtering or post-processing. Here, you analyze the responses the agent generates, checking for toxicity, bias, factual errors before they actually are shown to the user.
So checking what's going out makes sense.
Then you have behavioral constraints, often right in the prompt itself. These are direct instructions in the agent's core programming that guide its overall behavior, its tone.
Like telling it how to behave.
Exactly. And tool use restrictions, limiting what external tools the agent can access or how it can use them to prevent misuse or unintended consequences.
Right, don't let it run wild with powerful tools.
And finally, there's often human oversight or intervention, sometimes called human in the loop, designing specific points where a real person can review or even override the agent's decisions, especially for critical situations.
Okay, let's make this really concrete for your work. Input validation. I can see how that's crucial. Imagine detecting subtle distress signals or even overtly toxic language from a survivor. Guardrails could make sure the AI responds carefully or maybe immediately flags it for a human instead of just processing harmful words literally.
Right. Or triggering an insensitive automated response. And for output filtering, this means your AI would never give out, say, unverified legal advice or suggest unsafe coping strategies or share inaccurate helpline numbers. It would always guide users towards verified professional support.
That's non-negotiable.
Absolutely. And with behavioral constraints, you'd explicitly tell your AI, prioritize empathy, use non-judgmental language, practice active listening, stick to factual accuracy every single time.
Building the right character, essentially.
Yes. And tool use restrictions become vital for privacy. You ensure the AI can only access, say, your pre-approved, vetted database of crisis shelters or resources. It can't just browse the web or access systems that might contain identifying information, protecting the survivor's safety and confidentiality.
And that human oversight piece. That brings up a big design question, doesn't it? For those really sensitive or ambiguous situations in domestic violence crisis response, you have to decide, when must a human counselor step in? And how does the AI handle that handoff smoothly, gracefully?
It's a critical part of the design. This whole layered approach, though, is what makes the system truly robust and trustworthy.
We see guardrails in action all over. You mentioned customer service chatbots. You've built those. Guardrails there, stop offensive language, bad advice, off-topic rambling.
Exactly. And for your domestic violence crisis chatbot, it's even more critical. Guardrails can spot toxic input, maybe a threat to self or others, and instruct the bot to refuse to engage with that specific harmful topic. Or, more importantly, immediately escalate the whole conversation to a human crisis counselor, or even emergency services if needed.
It stays focused.
It ensures the bot stays laser-focused on its mission, providing crisis-relevant support and resources only.
Okay, let's talk tech a bit. How can we actually build these? Frameworks like Crew AI seem powerful here. They help implement these layers, right? Input sanitization, monitoring, error handling.
Yes, Crew AI gives you a good structure for this. The example in the source material shows how you can basically add a dedicated safety agent into your system.
A separate agent just for safety.
Right. This agent gets a specific policy prompt, like its rulebook and its output, is often validated using something like a Pydantic model. Pydantic, for those maybe not familiar, is a Python library that helps you define strict data structures. It's like creating a blueprint, ensuring any data moving through your code must fit an expected safe format.
So the Pydantic model acts like another check.
Exactly. It checks the structure. So this safety agent screens potentially problematic user inputs before they even get to your main AI. It's like a bouncer at the door.
I like that analogy. And that policy prompt, the rulebook, it's in there.
That's where you define the rules the safety agent enforces. It instructs the LLM to act as an AI content policy enforcer. It includes crucial directives like, first, blocking instruction subversion attempts. This is often called jailbreaking people, trying to trick the AI into ignoring its rules.
Ah, okay.
Stucking manipulation.
Second, preventing prohibited content directives. explicitly stopping the AI from generating anything discriminatory, hateful, abusive, or hazardous. For a crisis response AI, this is absolutely non-negotiable. User safety and service integrity depend on it.
Got it.
Third, avoiding irrelevant or off-domain discussions. Making sure your crisis bot doesn't get sidetracked into political debates, religious arguments, or just casual chit-chat. It has to stay focused on its specific mission.
Keep it on task.
Right. The policy also spells out the evaluation process. It's quite strict in the Crew AI example. If an input clearly violates any single rule, it's marked non-compliant. But if there's any doubt, it defaults to compliant.
That's an interesting balance. Defaulting to compliant if unsure. It is. It's a specific design choice. Maybe prioritizing not blocking potentially okay inputs over being hyper-cautious. We'll see a contrast later. But the key is the output is structured usually in JSON, so other parts of your system can easily read it and take action.
And you mentioned a technical guardrail too, besides the pedantic model?
Yes. Often you'll have a Python function, like the validate policy evaluation function in the example. It takes the raw output from the LLM, the safety agent, tries to parse it into the expected JSON format, validates it against that pedantic blueprint for structure, and then performs its own logical checks on the content.
So it's like a double check. LLM checks the policy content, Python checks the structure and logic.
Exactly. It's a really robust dual-layer validation approach.
And for this safety agent, you'd pick an LLM carefully.
You would. Maybe something fast and cost-effective like Gemini 2.0 Flash, and you'd set the temperature parameter very low, like 0.0. Low temperature makes the LLM output more deterministic, less creative, which is what you want for strict policy enforcement. Then you link this agent, its prompt, and that validation function together into a specific task within Crew AI.
Okay. And when you test this setup with different inputs, like asking for the capital of France versus asking how to hotwire a car,
it correctly identifies the safe query and blocks the harmful one.
Right. So for your crisis response AI, you could build similar test cases. You test how it handles expressions of distress respectfully, how it blocks requests for harmful advice, how it resists being jailbroken to talking about random stuff, and how it always points users towards safe, vetted resources.
This Crew AI example really gives you a practical blueprint for implementing that critical safety layer. Now, Google Cloud's Vertex AI offers another set of tools, another approach. It seems to focus a lot on things like agent and user identity, filtering inputs and outputs, but also on designing tools with safety built in and validating actions using callbacks. That's right. Vertex AI emphasizes a holistic approach. A really key practice there is defining a validation callback function, a piece of code that runs before any tool is called by the agent.
Before. Okay, tell me more.
Think of it as a security gate. Imagine your AI has a tool that could potentially access or share highly sensitive user information. This before tool callback function can run first, check if the user making the request is authorized, or if the context is safe. If not, it can block the tool call entirely.
I see. So it's a proactive check right before a potentially risky action. For protecting survivor privacy and data integrity, that sounds incredibly valuable, making sure sensitive tools only activate under verified safe conditions.
Precisely. It's a fundamental security control point.
You mentioned jailbreak attempts earlier, people trying to trick the AI. Vertex AI uses prompt-based safety measures against those too, right? Like Crew AI.
Yes. Similar idea. Using a carefully crafted prompt to instruct an LLM to act as a safety guardrail, identifying and blocking malicious inputs designed to bypass safety features.
What's interesting is the slight difference in philosophy, maybe. You noted the Crew AI example defaults to compliant, if unsure. The source mentions a Vertex AI safety prompt might say something different.
Right. It might instruct the safety LLM if you're genuinely unsure whether an input is unsafe, err on the side of caution and decide safe.
Wait, decide safe if unsure. That seems counterintuitive. Did I get that right? Let me reread that. No, it says err on the side of caution and decide safe. Okay, that's still a bit confusing wording in the original source, maybe? Let's clarify the likely intent. Usually, erring on the side of caution means assuming something is unsafe if unsure. Let's assume the intended meaning, common in safety design, is, if unsure, classify as unsafe or non-compliant. The Crew AI example explicitly said default to compliant if ambiguous.
Yes. Assuming the standard safety approach, the Vertex AI example likely intends to default to non-compliant or unsafe when unsure, contrasting with the Crew AI example's default to compliant. This highlights a really important design decision you have to make. How do you balance strict safety with ensuring the AI remains useful and doesn't block legitimate requests?
For crisis response, I imagine leaning towards the stricter, assume unsafe if unsure approach is probably the way to go.
Almost certainly. The cost of a false negative, letting something harmful through, is far too high in that context.
Okay, stepping back a bit. Building these reliable agents, it's not just about prompts and safety layers. It sounds like it requires real software engineering discipline.
Absolutely. Agents are complex systems. They can exhibit unpredictable emergent behavior. You have to apply the same rigor you'd use for building any critical software.
Like what kind of practices?
We'll take the checkpoint and rollback pattern. It's similar to how databases handle transactions. You periodically save a validated state, a checkpoint. If something goes wrong later, the system can roll back to the last known good state. It turns error recovery into a proactive quality assurance strategy.
Okay, like having save points. What else?
Modularity and separation of concerns. This is huge. Trying to build one giant monolithic agent that does everything.
Yeah.
It's just asking for trouble. It becomes brittle, hard to test, hard to maintain.
So break it down.
Yes. The best practice is to design a system of smaller, specialized agents or tools that collaborate. For your crisis response AI, instead of one agent trying to do intake, resource lookup, emotional support, safety planning, and human escalation.
You'd have separate agents or modules for each of those?
Exactly. That modular design makes the whole system easier to build, test, debug, and update. It enhances performance, agility, and fault isolation. If one part has an issue, it doesn't necessarily bring down the entire system.
That makes a lot of sense. And understanding what's going on inside.
That's where observability through structured logging comes in. A reliable system is one you can understand. You need deep observability. This means implementing structured logs that capture the agent's entire chain of thought.
What does that mean, chain of thought?
It means logging. Things like, which tools did it decide to call? What data did it receive back? What was its reasoning for the next step? What was its confidence level? This detailed logging is absolutely essential for debugging problems and tuning performance.
Got it. Visibility is key.
And finally, a core security principle. The principle of least privilege.
Give it only the permissions it absolutely needs.
Precisely. An agent should be granted the absolute minimum set of permissions required to perform its specific task. So an AI agent designed to connect survivors to local shelters, it should only have access to a safe, vetted list of shelters.
It shouldn't be able to browse random websites or access internal HR systems or anything else.
Exactly. This drastically limits the potential damage of the blast radius if something goes wrong, whether it's an error or a malicious exploit. And that's crucial when you're protecting vulnerable individuals.
Okay, let's quickly recap guardrails. They're essential for building responsible, ethical, safe agents. They stop harmful, biased, or off-topic responses.
And they're best implemented in layers. Input validation, output filtering, behavioral prompts, tool restrictions, human oversight. A combination provides the most robust protection.
They need ongoing attention monitoring, evaluation, refinement.
And treating agents like complex software, applying those proven engineering practices, fault tolerance, modularity, observability, least privilege is the most effective way to build reliable production-grade systems, especially for high-stakes work like yours.
All right, we've built in safety with guardrails, but how do we know if the AI is actually working well and continues to work well over time? That brings us to evaluation and monitoring.
Exactly. This isn't a one-time check. It's about systematically assessing your agent's performance, tracking its progress towards its goals, and crucially, detecting any operational anomalies or unexpected behaviors that might crop up later.
And why is this continuous part so important for AI?
Because unlike traditional software, which tends to be deterministic, AI agents often operate probabilistically in complex dynamic environments. Their performance isn't fixed. It can subtly degrade over time.
Degrade how?
Things like data drift, the kind of language users use might change, or the context shifts, or maybe there are just unexpected interactions the AI wasn't specifically trained for. So its effectiveness can change.
Okay, so you can't just launch it and assume it'll stay good forever.
Definitely not. You need continuous, often external measurement of its effectiveness, its efficiency, its compliance with your rules and ethical guidelines. It means defining clear metrics, setting up feedback loops, implementing good reporting systems.
So, for your domestic violence crisis response AI, this is critical. The environment it operates in is constantly in flux. Survivor needs change, language evolves, maybe the effectiveness of certain support resources changes. You don't just need to know if it worked at launch.
You need to continuously ensure it's working safely, effectively, and ethically, months, even years later. What does this really mean for building that ongoing trust and ensuring the well-being of the people you're serving? It means constant vigilance.
It moves way beyond just standard software tests, then.
Oh, yeah. Standard code tests often give you a predictable pass-fail. Agents are probabilistic, evaluation needs to be ongoing, and often measure things that aren't simple pass-fail.
How do we approach this? Are there best practices?
There are. Think of a kind of pyramid of practices for good evaluation and monitoring. At the base, absolutely fundamental. 1. Define clear, measurable objectives and indicators. What does success actually look like for your crisis response AI? Is it about response time, resolution rate, maybe user-reported helpfulness? You need to define.
Okay, know what you're measuring.
2. Use a combination of quantitative and qualitative data. Don't just count things like number of interactions. You need to understand the quality of those interactions. Were they empathetic, helpful?
Numbers and meaning. Got it.
3. Collect data regularly and consistently. This helps you spot trends, patterns, and anomalies early before they become big problems.
Keep watching.
4 and 5 are related to feedback and improvement. Reward and incentivize desired outcomes. For AI, this translates to optimizing for those outcomes, and provide feedback and coaching using the evaluation results to actively refine and improve the AI's models and prompts.
So it's a cycle. Measure, learn, improve.
Exactly. These practices are crucial for that continuous improvement loop and making sure your AI stays aligned with its mission in a live environment.
What are some practical ways we apply this?
Lots of ways. There's performance tracking in live systems, like tracking that chatbot resolution rate or response time we mentioned. There's A/B testing, trying out different agent strategies or prompts to see which performs better.
Comparing versions.
Right. You can conduct compliance and safety audits, specifically checking if the agent is sticking to ethical guidelines or regulations. Drift detection, actively monitoring for signs that performance is degrading because the input data or user behavior has changed.
Catching problems as they emerge.
And anomaly detection, identifying unusual or unexpected actions by the agent that might signal a bug, a security issue, or some kind of unintended emergent behavior.
All of those sound directly relevant to the crisis response work. Imagine A/B testing 2 different ways of phrasing empathetic responses to see which ones survivors report as more helpful.
Definitely. Or running regular audits to ensure the AI consistently follows trauma-informed care principles or adheres to privacy regulations like HIPAA is applicable.
Or detecting drift if the AI starts misunderstanding new slang terms people use when expressing urgency.
Or spotting an anomaly where the agent suddenly starts recommending an outdated resource that could indicate a problem with its knowledge base or tool usage.
Okay, let's talk metrics. When we evaluate an agent's response, just checking for accuracy with simple string comparison often falls short, right?
Hugely short. The example given is perfect. If the agent says, Paris is the capital of France, and the expected answer is the capital of France is Paris, a basic string match would score at 0.0 accuracy, which is clearly wrong. It's semantically identical.
So we need something smarter.
We do. We need more sophisticated natural language processing or NLP techniques. Things like string similarity measures beyond exact match, like Levenstein distance or Jacquard similarity, keyword analysis, and really importantly, semantic similarity. This uses embedding models' complex representations of word meanings to understand if 2 pieces of text mean the same thing, even if they use different words.
Right. Understanding the meaning, not just the letters. For your crisis response AI, this is vital. Accuracy isn't just about facts. It's about understanding the nuance, the tone, the underlying need. It's about providing responses that are genuinely helpful, empathetic, emotionally intelligent.
Semantic similarity helps ensure the AI grasps the true depth and intent behind what a user is saying, especially if they're distressed, and maybe not communicating clearly or directly. Simple string matching just won't cut it.
Beyond the content of the response, what else should we monitor?
Latency monitoring is absolutely critical, especially for real-time interaction. How long does the agent take to process a request and generate a response?
In a crisis situation, a slow response could be terrible.
Catastrophic, potentially. So, logging latency data maybe to structured log files, time series databases like InfluxDB or Prometheus, or observability platforms like Datadog or Splunk is essential for optimizing how responsive your support AI is.
And you also need to track resource use, like tokens.
Yes, token usage. LLMs are often built based on the number of tokens processed, input and output. Tracking this is crucial for managing costs.
Yeah.
But it's also helpful for optimizing resource allocation and identifying if your prompts are maybe inefficiently long or causing the model to generate overly verbose responses.
Okay, so we can measure accuracy smartly, latency, cost. But what about those subjective qualities, like how helpful or empathetic is the AI? That seems hard to measure objectively.
It is incredibly hard with standard metrics. And this is where a really fascinating technique comes in, the LLM as a judge approach.
Using an LLM to judge another LLM.
Exactly. You leverage a separate powerful LLM, give it a specific rubric or set of criteria, and ask it to evaluate the output of your primary AI agent based on those subjective qualities like helpfulness, empathy, clarity, etc.
Wow, that sounds potentially game-changing for this kind of work.
It really is. Because how else do you objectively measure at scale if an AI providing crisis support is truly helpful or empathetic or trauma-informed or effective at de-escalation? An LLM as a judge, armed with a carefully designed rubric, can provide nuanced, human-like evaluations that go way beyond simple keyword check.
Can you give an example, like that legal survey rubric mentioned?
Right. That example rubric defines criteria for evaluating legal survey questions, things like clarity, neutrality, relevance, completeness, appropriateness. Each gets a score, say 1 to 5, and the judge LLM has to provide a detailed rationale and specific feedback.
So you could adapt that concept, create an LLM as a crisis counselor judge.
Precisely. You develop a rubric defining key aspects of quality crisis support, maybe empathy level, non-judgmental language score, resource accuracy, de-escalation effectiveness, adherence to trauma-informed principles. The judge LLM would then evaluate transcripts of your AI's interactions against this rubric.
And it would output structured feedback.
Yes, usually structured JSON output, maybe with an overall score, a rationale, detailed feedback points, concerns, recommended actions. This makes the evaluation actionable, allowing you to systematically improve your AI's qualitative performance.
That's incredibly powerful for scaling up quality assessment, but it's not perfect, right? What are the trade-offs compared to, say, having humans review interactions?
Good question. There are trade-offs. Human evaluation. Still the gold standard for capturing subtle nuance, empathy, real-world impact. But it's slow, expensive, hard to scale, and can be inconsistent between reviewers. LLM is a judge. Much more scalable, faster, cheaper, and consistent given the same model and prompt. But its capabilities are limited by the judge LLM itself. It can still make mistakes, misunderstand nuance, or have biases. And designing the rubric is critical. Automated metrics like semantic similarity, latency, highly scalable, efficient, objective for what they measure. But they're limited in capturing the full picture, especially those subjective qualities.
So often the best strategy might be a mix. Use automated metrics for broad monitoring, LM as a judge for scalable qualitative checks, and targeted human review for the most critical or ambiguous cases.
That's often the most practical and robust approach, yes, blending the strengths of each method.
Okay, shifting gears slightly with an evaluation. For these intelligent agents, just looking at the final output isn't always enough, is it?
No, definitely not. Traditional software tests often focus on the final result.
Yeah.
But for agents, especially probabilistic ones or complex multi-agent systems, you often need to assess the trajectory, the sequence of steps, the reasoning process, the path the agent took to get to the solution.
Why is the path so important?
Because the final answer might be right by luck, or the agent might have taken a very inefficient or even unsafe path to get there. Understanding the how helps you identify errors in reasoning, inefficiencies, or unintended behaviors, especially when evaluating complex collaborations between multiple agents.
How do you evaluate a trajectory?
You typically compare the agent's actual sequence of actions, like tool calls, intermediate thoughts, to an expected or ground truth trajectory. There are different ways to measure the match. Exact match requires a perfect step-by-step match to the ideal sequence. Very strict.
Okay.
In-order match. Checks if the correct actions occurred in the correct order, but allows for extra, potentially unnecessary steps in between. More flexible. Any order match. Checks if all the correct actions occurred, regardless of order, and allows extra steps. Even more flexible. There are also metrics like precision, how many of the agent's actions were relevant, and recall, how many of the necessary actions did the agent actually take.
So the metric you choose depends on how strict you need to be.
Exactly. For a critical safety planning protocol in your crisis response AI, you might demand an exact match for certain crucial steps. For less critical tasks, maybe an in-order or any order match is sufficient. It depends entirely on the requirements of the specific task.
How do you define these ground truth trajectories for testing?
Frameworks like Google's Agent Development Kit, ADK, provide structured ways to do this. They differentiate between two main types of files. Test files. These are usually JSON files representing a single, relatively simple agent model interaction or maybe a short session. They're great for unit testing specific behaviors during active development because they run quickly. A test file might detail a user asking the agent to do something specific and then list the expected sequence of tool calls and the expected final response.
Like testing one specific skill in isolation.
Pretty much. Then there are Evals files. These are typically larger data sets containing multiple, potentially much longer and more complex, multi-turn conversations or sessions. They're better suited for integration testing, simulating more realistic interactions, and evaluating the agent's ability to maintain context and handle more elaborate tasks.
So test files for quick checks, Evals files for deeper, more realistic simulations.
That's a good way to think about it.
Now, there's a really interesting idea mentioned about an evolution from simple agents to something called advanced contractors. What's that about?
It's a proposed shift in how we think about building reliable AI for complex tasks. The idea is to move away from systems that are primarily probabilistic and sometimes unreliable towards agents that operate more deterministically and are more accountable, especially for high-stakes work.
More like hiring a human contractor with a clear agreement.
That's exactly the analogy. This transformation is built on 4 key pillars. 1. A formalized contract. This isn't just a simple prompt, it's a detailed specification. Think of a legal contract serving as the single source of truth for a task. It explicitly defines the deliverables, the exact specifications, data sources, scope, even constraints like cost or completion time. This makes the outcome objectively verifiable. Okay, so instead of just saying analyze sales data, the contract would be super specific. Right. It might say produce a 20-page PDF report analyzing European market sales for Q1 2025, including 5 specific data visualizations listed, a comparative analysis against Q1 2024, and a risk assessment based on factors X, Y, and Z using only the verified internal sales database.
Wow, that's detailed. How does that apply to the crisis response work?
Imagine a contract for your AI. Draft a personalized safety plan for survivor profile #123, ensuring it includes verified local resources from the approved shelters database, references the trauma-informed language guide v2.1, is delivered in a secure encrypted format, AES 256, and completed within 10 minutes of receiving the intake form.
That level of detail brings real accountability and predictability.
Exactly. Pillar 2 is a dynamic life cycle of negotiation and feedback. The contract isn't just handed down. The contractor agent can analyze the terms, maybe identify issues, and negotiate.
Negotiate, an AI negotiator.
Conceptually, yes. If the contract requires data from a source the agent can't access, it could provide feedback like, the specified XYZ database is inaccessible. Please provide credentials or approve the use of alternative public database ABC. This helps resolve misunderstandings before execution starts, preventing wasted effort and failures.
Smart. What's pillar 3?
Quality-focused iterative execution. Unlike agents optimized purely for speed or low latency, a contractor agent prioritizes correctness and quality. It might involve steps like self-validation, generating multiple potential solutions, testing them against criteria defined in the contract, scoring them, and only submitting the version that passes all checks.
So built-in quality control.
Yes. And pillar 4 is hierarchical decomposition via subcontracts. For really complex tasks, a primary contractor agent can act like a project manager. It breaks the main goal down into smaller, manageable subtasks, each defined by its own formal subcontract, potentially assigned to other specialized contractor agents.
Like breaking down, building a whole application into subcontracts for UI, database, authentication, etc.
Precisely. This allows the system to tackle massive, multifaceted projects in a structured, accountable way.
This whole contractor framework sounds like it could fundamentally change how we build and trust complex AI systems.
It really reimagines AI interaction by embedding formal specification, negotiation, and verifiable execution right into the agent's core logic. The aim is to make AI a truly dependable, auditable, and trustworthy system capable of autonomously managing complex projects.
Okay, so wrapping up evaluation and monitoring, key takeaways. It's way beyond traditional tests. It requires continuous, multifaceted assessment in the real world.
Practical uses include performance tracking, A/B testing, compliance audits, detecting drift or anomalies. Basic accuracy isn't enough. You need sophisticated metrics like semantic similarity, latency, token tracking, and maybe LM as a judge for subjective qualities like helpfulness.
Analyzing the agent's trajectory, the path it takes, is crucial for understanding its reasoning and finding problems. Frameworks like Google's ADK help structure this with test files and Evals files.
And the whole field might be moving towards this paradigm of formal contracts for agents, aiming for verifiable deliverables, negotiation, self-validation, transforming them into accountable, reliable systems for those really high-stakes tasks.
Okay, we've covered safety with guardrails and ensuring ongoing effectiveness with evaluation. Now let's talk about prioritization. Agents often face situations where they could do many different things, right?
Absolutely. In complex, dynamic environments, they constantly encounter numerous potential actions, maybe conflicting goals, and almost always limited resources, time, computation, access to tools.
And without a clear way to decide what to do next, they could just flounder or do the wrong thing.
Exactly. They might become inefficient, experience delays, or completely fail to address the most important objectives. The prioritization pattern is designed specifically to solve this challenge of choice.
This sounds incredibly relevant for your work. I mean, in a domestic violence crisis response setting, every second matters.
It really does.
You could have incoming requests ranging from someone in immediate life-threatening danger to someone asking for information about long-term support groups. The AI has to be able to tell the difference and act accordingly.
This is where prioritization becomes, quite literally, a potential lifesaver. The agent needs an intelligent way to decide. Is this situation a P0 highest possible priority requiring immediate escalation to a human? Or is it maybe a P2 lower priority request for general info that can be handled systematically when resources allow?
An agent without that ability could get completely overwhelmed, waste time on less critical tasks, and fail to address the most urgent needs. The consequences could be dire.
Precisely. So agents use prioritization to effectively manage their tasks, their goals, their sub-goals. It guides their subsequent actions. It allows them to make informed decisions even when facing multiple demands, resource constraints, or conflicting objectives.
How do they actually do this? What are the core elements?
There are a few fundamental aspects involved. First, criteria definition. You need to establish the rules or metrics the agent will use to evaluate tasks. What makes something important?
Like what?
Criteria often include things like urgency. How time-sensitive is it? Importance. What's its impact on the main goal? Dependencies. Does another task need this one finished first? Resource availability. Do we have what we need to do it now? Maybe cost-benefit analysis, or even user preferences.
Okay. And for your crisis response, AI, defining those criteria would be crucial. Urgency might be triggered by specific keywords indicating immediate danger. Importance could relate to the potential for harm reduction. Dependencies might involve needing basic info before providing specific resources.
Exactly. You define what matters. Second, task evaluation. The agent assesses each potential task against those criteria you defined. This could range from simple rule-based checks to more complex scoring systems, or even using an LLM to reason about the priorities.
So weigh the options.
Third, scheduling or selection logic. This is the algorithm or mechanism that actually selects the optimal next action, or maybe orders a sequence of tasks based on those evaluations. It's the decision-making part.
Picking the winner.
And fourth, dynamic reprioritization. This is really important. The agent needs the ability to change priorities as the situation evolves. A new critical event might occur. A deadline might approach. The agent needs to adapt and respond dynamically.
It can't be rigid. Needs to adjust on the fly.
Correct. And prioritization isn't just one level. It can happen when selecting a high-level goal, or when ordering the steps within a plan, or even when choosing the very next immediate action to take.
Makes sense. We see prioritization everywhere in AI, right? Not just chatbots.
Oh, absolutely. Think about cloud computing systems prioritize resource allocation based on demand and service level agreements. Autonomous driving systems constantly prioritize collision avoidance over, say, fuel efficiency or route speed.
Right. Safety first.
Financial trading bots prioritize executing high-value or time-sensitive transactions. Project management tools prioritize tasks based on deadlines and dependencies. Cybersecurity systems prioritize alerts based on threat severity. Even personal assistant AIs prioritize managing your calendar or reminders based on urgency.
Let's bring it back to automated customer support, since that's familiar ground for you. How does prioritization work there?
Typically, support agents prioritize urgent requests like reports of a major system outage over more routine issues like someone needing a password reset. They might also give preferential treatment or faster response times to customers flagged as high value.
Okay, I see the parallel. For a domestic violence crisis response bot, that translates directly. A message containing keywords indicating immediate danger or distress would be instantly flagged as P0.
And that P0 flag might trigger an immediate alert to a human supervisor or counselor.
Whereas a request for general information about local support groups, while still important, might be classified as P1 or P2. It gets handled systematically, but doesn't necessarily jump the queue ahead of a life-threatening emergency.
Exactly. This ensures the most critical needs are always addressed first. It optimizes the allocation of limited resources, whether that's AI processing time or human counselor attention, for maximum positive impact.
Can we see this in code? The LangChain example of a project manager AI seems relevant here.
Yes, that's a great illustration. This code demonstrates building an agent using LangChain that can help manage project tasks, creating them, prioritizing them, assigning them to team members. It shows how an LLM, combined with custom tools, can automate this kind of workflow.
What are the key pieces? There's a super simple task manager.
Right. It's basically an efficient, in-memory way to keep track of tasks. It uses a Python dictionary for fast lookups, and it uses a pedantic model. There's pedantic again, ensuring structure called task to define what a task looks like. It has an ID, a description, an optional priority, P0, P1, or P2, and an optional assignee.
Okay, a simple task tracker. And the agent interacts with it using tools.
Correct. The project manager agent is given specific tools it can use. Create a task lets it add a new task and get back the task ID. Assign priority task lets it set the priority, P1, P2, for a given task ID. Assign task worker lets it assign a task ID to a specific worker. And list tasks just shows all the current tasks. Importantly, the arguments for these tools, like what priority to set or who to assign it to, are also defined using pedantic models. This makes the interaction between the LLM and the tools much more reliable and less error-prone.
Got it. Tools with clear inputs. And the agent's behavior is guided by a prompt.
Yes, the PIM prompt template. This system prompt tells the agent what it is and what to do. It defines its role as a focused project manager LLM agent with the goal to manage project tasks efficiently.
And it gives specific instructions.
It does. It tells the agent the workflow. First, always use create new task to get an ID for a new request. Then analyze the request to see if a priority or assignee was mentioned and use the appropriate tools if so.
What if the user doesn't specify a priority or assignee?
This is a key part of the prompt design for robustness. The prompt explicitly tells the agent, if priority or assignee information is missing in the user's request, you must make a reasonable default assignment. For example, assign a default priority of P1 and assign it to a default worker like worker A.
Oh, that's smart. So it doesn't just fail if the input is incomplete. It makes a sensible guess.
Exactly. It handles ambiguity gracefully. The prompt also provides the agent with the allowed priority levels, P0, P1, P2, and the list of available workers, worker A, worker B, to guide its choices.
And then the agent executor in LangChain ties the LLM, the tools, and the prompt together.
Yes, along with memory, conversation buffer memory, so the agent can remember the context of the conversation. Setting verbose. True, when running it is really helpful because it prints out the agent's internal chain of thought. You can see exactly which tools it decides to call, what inputs it uses, and what results it gets back.
Yeah.
Great for debugging and understanding.
The example runs a simulation with two scenarios.
Right. Scenario 1 is an urgent request for a new login feature, explicitly assigned to worker B. This shows the agent correctly interpreting urgent, mapping it to P0 priority, and handling the specific assignment.
Okay.
Scenario 2 is a less urgent request for a content update, but it doesn't specify priority or assignee. This tests the agent's ability to apply those default assignments we talked about. P1 priority, worker A.
I can totally see how this applies to managing a queue of crisis support requests. Your AI could receive a new message from a survivor. It uses its tools and reasoning, guided by its prompt and criteria, to automatically categorize the urgency: P0 for immediate danger, P1 for safety planning help, P2 for general resource info.
And then it could use another tool to assign that request with its priority level to the right place, maybe a specific human counselor queue based on urgency, or perhaps an AI sub-agent specialized in handling resource requests, depending on availability and specialization.
And it logs everything in a task management system. This ensures no request gets lost, and the most critical needs always get addressed first. It brings structure and efficiency to potentially chaotic situations.
That's the power of effective prioritization in action.
Okay, let's summarize prioritization. It's what enables agents to work effectively when faced with complexity, conflicting goals, and limited resources.
They use defined criteria, urgency, importance, dependencies to evaluate and rank tasks. Dynamic reprioritization lets them adapt to changing situations in real time.
It happens at multiple levels, from big goals down to immediate actions.
And the result? Increased efficiency, better operational robustness, and making sure the agent stays aligned with its strategic goals. Absolutely vital for impact, especially in critical domains.
All right, we've covered making agents safe, ensuring they work well over time, and helping them make the right choices. Now for something really forward-looking: exploration and discovery.
This pattern is about enabling agents to go beyond their current knowledge and actively seek out novel information, uncover new possibilities, maybe even identify those unknown unknowns within their operating environment.
So it's not just reacting or optimizing based on what it already knows.
Exactly. It's fundamentally different from reactive behaviors or just trying to find the best solution within a predefined space. It's about expanding the boundaries of what the agent knows and can do.
Why is this important?
It's crucial for agents operating in domains that are open-ended, really complex, or changing rapidly. Think scientific research, market analysis, or even understanding evolving social issues. In these areas, static knowledge or pre-programmed solutions just aren't enough for true innovation or deep understanding.
Okay, let's connect this to your mission again. Domestic violence crisis response. The landscape of survivor needs, the resources available, the best intervention practices, it's constantly evolving, isn't it?
Absolutely. It's incredibly dynamic.
So what if your AI could do more than just respond to requests based on its current programming? What if it could proactively discover new patterns in survivor needs, identify emerging risk factors, or even find better, previously unknown ways to connect survivors with the right kind of support?
That's the potential here. Exploration and discovery allows the AI system itself to expand its understanding and capabilities, potentially leading to breakthroughs in how support is provided. It moves the AI from just an assistant to potentially a partner in innovation.
Where are we seeing this kind of capability today?
AI's ability to explore intelligently is leading to applications across many fields. We see it in scientific research automation, obviously. In game playing and strategy generation, think AlphaGo discovering novel strategies in Go. In market research and trend spotting. Even in security vulnerability discovery, where AI proactively searches for weaknesses.
Creative content generation, personalized education, it seems broadly applicable.
It is. A really striking example from the source material is Google Co-Scientist.
Tell me about that. It sounds ambitious.
It is. It's a cutting-edge AI system from Google Research, designed explicitly as a computational collaborator for scientists. It uses the Gemini LLM to assist human researchers in critical, challenging parts of the scientific process.
Like what parts?
Things like generating novel hypotheses, helping refine research proposals, even assisting with experimental design. It's built to tackle bottlenecks in research, like sifting through massive amounts of existing literature, generating truly testable hypotheses, not just vague ideas, and managing the complexity of planning experiments. The goal is to augment human creativity and cognition.
How does it work? Is it just one giant AI?
No, it's based on a multi-agent framework. It's structured to mimic how human scientists collaborate and iterate. There's a kind of supervisor agent coordinating several specialized AI agents.
Like a research team?
Sort of, yeah.
Yeah.
You have a generation agent that starts things off, maybe by exploring literature and simulating debates to produce initial hypotheses. Then a reflection agent acts like a critical peer reviewer, checking for correctness, novelty, quality.
Okay, generation and critique.
Then a ranking agent might use methods like an ELO rating system, like in chess, to compare, rank, and prioritize the hypotheses. An evolution agent takes the top-ranked ideas and tries to refine them further, maybe exploring unconventional lines of reasoning.
Constantly improving the ideas.
Right. There might also be a proximity agent that maps out how similar different ideas are, clustering them together. And a meta-review agent that looks at the whole process, the reviews, the debates, to identify patterns and suggest ways to improve the system's overall performance over time.
Wow, that's complex. And it follows a specific methodology.
Yes, its core methodology is described as generate, debate, and evolve. It mirrors the scientific method, engaging in this self-improving cycle of generating ideas, critically evaluating them, and refining the best ones.
Did it actually work? What were the results?
The validation studies reported are, frankly, remarkable, especially in biomedicine.
Like what?
Well, on standardized tests, it performed extremely well, sometimes outperforming other state-of-the-art AI models and even human experts on difficult scientific reasoning problems. Expert biomedical researchers rated the hypotheses it generated as being more novel and impactful than those from human experts in some cases.
More novel than humans, seriously.
That's what the research suggests for certain tasks. But even more impressive are the end-to-end experimental validations.
Meaning they actually tested its ideas in the lab.
Yes. For drug repurposing, it proposed novel drug candidates for acute myeloid leukemia, AML. Some of these were completely new ideas, and when tested experimentally, they're confirmed to inhibit the viability of tumor cells.
So the AI discovered potential cancer treatments that worked in the lab?
It proposed them, and they were experimentally validated. Similarly, it identified novel biological targets for liver fibrosis, which were also validated in lab experiments using human liver organoids.
Incredible.
Perhaps most striking. In the field of antimicrobial resistance, the system apparently independently rediscovered an unpublished experimental finding in just 2 days. A finding that had taken an independent human research group over a decade to discover.
2 days versus 10 years? That's mind-blowing.
It highlights the potential speed and power of this approach for accelerating discovery.
Okay, let's bring this back. This raises a huge question for your work. If AI can do that in biomedicine, could you adapt a similar multi-agent system for understanding domestic violence?
It's a fascinating thought.
Could an AI generate and evaluate hypotheses about why certain support interventions seem more effective for survivors from specific demographic groups? Could it safely analyze large volumes of anonymized crisis call data to discover new risk factors? Or identify emerging patterns and support needs that humans, with our limited processing power, might be missing?
Potentially, yes. This kind of system could move your AI beyond just providing reactive support. It could become a tool for generating proactive, evidence-based insights, a strategic assistant that truly augments human expertise and understanding in the field.
But the safety aspect here feels even more critical than in other domains.
Absolutely paramount. And the co-scientist research emphasizes this. It's designed as a scientist in the loop, a collaborative paradigm, not full automation. They acknowledge limitations, like relying on publicly available literature, which often has publication bias towards positive results, and the ever-present risk of LLM hallucinations, generating plausible but false information.
And they have safety checks.
Very robust ones, according to the description. All research goals and generated hypotheses are reviewed to prevent unsafe or unethical use. Dangerous inputs are rejected. It reinforces that even with these incredibly advanced agentic systems, those fundamental guardrails we discussed earlier are absolutely non-negotiable.
Okay, another example mentioned is Agent Laboratory. What's that?
Agent Laboratory is described as an autonomous research workflow framework. It's also designed to augment human science by automating different stages of the research process. It even has a component called Agent Oxford, like a decentralized Oxford repository, specifically for sharing research done by these autonomous agents.
So agents publishing their own findings?
Conceptually, yes, facilitating sharing and building upon AI-driven discoveries. The framework breaks research into distinct phases, with specialized agents for each. Literature review. LLM agents collect and critically analyze relevant papers using databases like ArcVef, experimentation. Agents collaborate to formulate experimental designs, prepare data, run experiments using integrated tools like Python for coding or Hugging Face for models, analyze results, and iterate. Report writing, automating the generation of research reports, synthesizing findings, maybe even using tools like LaTeX for formatting. Knowledge sharing. Through Agent ArcVef, enabling agents to share and access findings.
What stood out about its evaluation process? Something about tripartite agentic judgment.
Yes, that's a really interesting aspect. Instead of just one metric or one judge, the system uses 3 distinct autonomous reviewer agents to evaluate research output. Each reviewer agent is configured with a specific persona or perspective.
Like different types of peer reviewers.
Exactly. One might be configured as a harsh but fair reviewer expecting good experiments. Another might be a harsh and critical but fair reviewer looking for impactful ideas. A third could be a harsh but fair, open-minded reviewer looking for novel ideas.
That mimics real peer review much better than a single score. It captures different facets of quality.
It aims to, yes.
Yep.
It moves beyond a single, potentially simplistic metric towards a richer, more multifaceted qualitative assessment. These reviewer agents are given a detailed prompt, asking for structured output in JSON format.
What kind of output?
Really comprehensive stuff. The JSON includes fields for summary, strengths, weaknesses, ratings for originality, quality, clarity, significance, any questions for the authors, identified limitations, ethical concerns, soundness, presentation quality, overall contribution, a 110 overall score, a confidence score for the review itself, and a final decision. accept, reject.
That's incredibly detailed. It shows a high level of sophistication in how these systems can evaluate complex work.
It does. And Agent Laboratory also uses specialized multi-agent roles, again mimicking academia. A professor agent acts as the research director, setting the agenda, defining questions, delegating. A postdoc agent does the main work, literature reviews, designing and implementing experiments, including writing and executing code for protocols and analysis, generating papers.
The postdoc agent actually codes.
Yes, a key capability. Then the reviewer agents evaluate the postdoc's output. There are even ML engineering agents and SW engineer agents that collaborate to generate similar code, like for data preprocessing, guided by the research plan.
This whole modular hierarchical structure, it's fascinating. Again, thinking about the domestic violence field.
You could imagine a similar structure. A professor agent could define a critical research question. What are the linguistic markers that best predict imminent escalation in crisis calls based on anonymized outcome data?
Then a postdoc agent could analyze anonymized transcripts, maybe use coding tools to develop and test classification models.
Reviewer agents could assess the validity and ethical implications of the findings. ML engineering agents could help build or refine the models based on the postdoc's research.
It provides a potential blueprint for using AI not just for direct support, but for generating crucial new knowledge and evidence within the field itself.
That's the promise of exploration and discovery patterns applied thoughtfully.
Okay, let's wrap up exploration and discovery. Key points. It's about AI agents actively pursuing new information and possibilities, going beyond reacting to what's already known, essential for complex, evolving domains.
Systems like Google Co-Scientist show how multi-agent frameworks can autonomously generate hypotheses, design experiments, and genuinely accelerate human scientific research, achieving remarkable results.
Frameworks like Agent Laboratory provide structure through specialized roles, automating stages like literature review, experimentation, and report writing, and using sophisticated multi-perspective evaluation.
Ultimately, the goal of these agentic systems is to enhance human creativity and problem solving. They handle the computationally intensive parts of discovery, accelerating innovation, but they absolutely require strong safety guardrails and continuous ethical oversight.
Wow. We have covered a ton of ground today. We set out to unlock agentic design patterns, give you that mental roadmap, and I really think we've done that.
It's been a deep dive for sure.
We started with the absolute necessity of guardrails, that foundation of safety and trust. Then, the critical importance of continuous evaluation and monitoring to ensure ongoing effectiveness and reliability. After that, the strategic power of prioritization for making smart, impactful decisions in complex situations. And we finished with a really exciting, transformative potential of exploration and discovery for finding genuinely innovative solutions.
And hopefully you've gained a solid understanding of how these patterns work, not just in theory, but seeing them in action through examples in Crew AI, Vertex AI, LangChain, and looking at those inspiring architectures like Co-Scientist and Agent Laboratory. These aren't just abstract ideas, they're practical, actionable tools.
Exactly. Tools that will empower you specifically to build even more robust, more ethical, and more impactful AI solutions for the domestic violence crisis response organizations you're aiming to support.
Thinking about how these patterns apply directly, ensuring every interaction is safe and trauma-informed with guardrails, dynamically prioritizing the most urgent pleas using prioritization, continuously evaluating helpfulness with evaluation techniques like LLM as a judge, maybe even discovering new insights or intervention strategies through exploration.
It all comes together to help you serve survivors more effectively, more reliably, always upholding the absolute highest standards of care.
Now, this field is moving incredibly fast. This deep dive gives you a really strong foundation, a great starting point. But the journey of learning and discovery, much like those exploration agents we talked about, it's ongoing. Keep learning, keep building.
Absolutely. And as you continue on this path, developing these advanced AI agents capable of such incredible things, ensuring safety, making smart decisions, even discovering new solutions. Here's a final thought to maybe mull over. How might we start to rethink the very definition of support and intervention in domestic violence crisis situations? As AI becomes capable of moving beyond just reactive measures, how can we leverage it for proactive, intelligent, and deeply compassionate assistance? Always keeping the human survivor and the human caregiver at the absolute heart of the solution.
That's a profound question. Shaping that future responsibly is the real challenge and the real opportunity.
Thank you for joining us on The Deep Dive. We'll see you next time.